but just your voice. So here we go. We're gonna be working combining like terms today, numerical and algebraic expressions. But we're also gonna review some terminologies that we might go along. Okay. So our goal is to simplify numerical and algebraic expressions by combining like terms. But before we start, I always ask you some question that you might like think. What do you think? What's your opinion? What's your idea about it? So this time says, what makes a star a star? So we all shine in our own way. So let's write something, one or two.
We cannot write on it.
Again, that is so sad. So think about it and I'll ask you in a few minutes.
Star represents a reflection of a bright future.
Yes.
And then if that's not what you wanted, a scientific explanation is a star is made of glass and helium, and they are very heavy and aren't actually yellow, they are mainly white.
I know, that is true. So both of what you said is correct. Emmy, would you like to read it? Emmy? So I'll read what Emmy wrote, okay? So in dreams, a shooting star is a sign of self-fulfillment and advancement in life. That is a very deep thought about what makes a star a star. So if we put this in a task for today is in your Google Classroom, we're gonna be working.
I think you should like turn your camera because it's gonna like lag.
Oh, okay. I know, right? I usually do turn it off. Let me see. Good suggestion. I forgot that. I usually turn on. So my camera is off. So what we're going to do today is just to find, simplify, group together coefficients and terms. So like, but we start off with the coefficient of a term is constant or a number that is multiplying the variable or variables of that term. The term is always has the coefficient. I'm gonna go to the worksheets that I give you, and I want to give you a little time to go to that worksheet and download it and let's work on it side by side. I'm gonna do the first 2 or 3 examples on this section and then you do on your own. All right, so I'll start with that, but I'll give you a time to like upload or see your in a Google Classroom your work. Your worksheet. Let's do this. In this lesson, we review the process in combining like terms, as well as review some terminologies associated with the terms that you've seen before. First, let's review the coefficient. What is a coefficient? Anybody, tell me what is a coefficient? Fiona.
Could turn the number.
It's the number of the term. MD? Is the coefficient and exponent the same?
No.
No, they are not. So if you look over here, exercise 1, for each of the following monomials, single term, right? All of them are in single term. Even though they are combined with multiplication or division, they are still single term. Terms are separated by addition and subtraction only. So the coefficient of the term of is the constant or a number that is multiplying the variable. That's to multiply the variable or variables of that term. That term always has a coefficient. Let's go back to that. Let's go look for that later on. So I'll answer to you 3 questions here. All right. So for number 1, what is the coefficient for 5x? What is the coefficient for 5x? MD?
Is it 5?
Yes. It's the number that multiplies variables. So here, for 5x, 5. How about for letter F? Fiona? Negative 4c. What's the coefficient for letter F?
-4.
Correct. Next, what's the coefficient of letter C? Anderson? Go ahead, Anderson. Ekis? You guys need to join, participate today. This is what we talked with Ms. Friedman today. Yes, Ekis, go ahead for letter C.
Half.
Huh?
Yeah, half.
Half is correct. My right too big. And the last example that I'm going to work with you, letter D. What's the coefficient for letter D? The expression is n. What is the coefficient for that? It says a term always has a coefficient. Who is raising hand? Malia.
1.
1. So remember that, guys. 1 is the coefficient for that. If you don't see a number before that, that's 1. If you don't see an exponent, that exponent is also 1. With that said, you guys gonna be given at least 2 minutes to complete the other questions in this part. Okay? 2 minutes, and then I'll go with exercise number 2. Alright, so time's up. So I'm gonna clear this one and we go to the next. So exercise number 2. This is easy, right? So because of the importance of multiplication in the distributive property, it is important that we can properly identify coefficient even in trickier ones. So let us now start to understand the combining like terms. So for each of the following, rewrite the sum as product. Do not need to evaluate any of the products. So let's look at this. Look at number 1. 3 plus 3 plus 3 plus 3. How are we going to rewrite this as a multiplication problem or expression? How could we create an expression that is also equivalent to 3 plus 3 plus 3 plus 3, but using a multiplication expression? 30 seconds. All right. Malia, would you like to try number 1? How are we
Sure.
going
You could do 5 times 3 or 3 times 5.
So that's 1, 2, 3, 4. It's only 4. 5. 1, 2, 3, 4, 5. You're right. So that's gonna be 5. I'm not gonna use any more x because we're doing expression, and usually x is a variable that we use to represent a variable. So we could do parentheses since that's a number to multiply it to 3. It says we don't need to simplify or evaluate. That's very correct. How about letter D? Let's see somebody else. How about Danae? Letter D, it's x plus x plus x plus x plus x again. So how do we rewrite letter B as a multiplication expression? I'll pass by Malia. I'll come back. I mean Danae. MD, go ahead.
Is it 5x?
That is very correct. See, that's why I said if we eliminate using x as a multiplication sign, because we don't need to do that. We just put them together, 5x. All right. So I want you to answer C and D, and then we'll work on exercise number 3. For C and D, it's easy, so I'll give you like 1 minute only. All right, go ahead. All right, time's up. So we clear this and we'll move to the next. Okay, so let's go to, I could not move it. Let me go out. So let's go to exercise number 3. All right, for exercise number 3, write each of the following terms as sums instead of product. So I'm gonna write each of this term as sum of them, not the product of it. How are you gonna write that? Who would like to bravely do the answer? Teresa? Who raised hand? Oh, Katie. Let's go, Katie.
You would write it in like an addition form.
Yes. For letter A.
4 plus 4. x plus x plus x plus x.
Correct. That's true. You know what's so funny? In my previous class, they said, let me finish this one. So the first one that I asked, I was even like also scared that you guys gonna say it. Others said 4 plus x. I never said, wait, if 4 plus x, it's 4 plus x. If x is 2, so that's only 6. But this is 4 times 2. And that will be a different answer. So I was like telling them, what? Okay. With that said, I want you to do now letter B and letter C on your own. 30 seconds. All right. So let's do this. So write both, consider the sum of 5x plus 3x. We would like to simplify it, okay? So we both write both 5x and 3x as extended sums, like what we did in exercise number 4. And then A, use these answers to rewrite
Exercise number 4?
5x. Wait, consider, the previous one. In exercise 4. I think it was exercise 3. That's what they're talking about, right? So let's try to do this. I'll do the letter A with you. So write both 5x and 3x as extended sum. Fiona, what is the extended sum of 5x?
X plus x plus x plus x.
I feel like this is like too baby, right? But it's good to like review. How many is that? 1, 2, 3, 4, 5. And Aaron, can you do the next one? What's this? What is the extended sum form of 3x? It's so obvious, correct? So they're gonna be what? I'm just gonna go ahead. X plus x plus x. Wow, it looks like all plus. Just imagine that's x. All right, question is, how many x's do we have now? How many x's do we have in this case?
8.
We have 8 what? 8,
8x.
8x. So we could just say that 5x plus 3x equals, what did you say before? How many x's? 8x. So I like the way NGLS describe it to us. And now, how could we find the simplified answer for this using the coefficient? So we have the coefficient for this problem is 8. Okay. So we said to simplify the sum or difference of like terms, we only need to add and subtract the coefficients. We only had to add and subtract the coefficient. It becomes 8x. Of the terms like the one that we have just here. It is important to be able to recognize like terms when you see them. How will you know that they are like terms? Like terms are those terms in an expression that have the same variable raised to same exponent. So those are the two categories that you had to remember that they are like terms. If it is x and y, then they are not the same term. If it is power of 2 and power of 3, they are not the same term, even though they are x. For example, x squared and then plus x cubed, that is not the same term. So you cannot add them together. All right, so the condition is it must have the same variable and the same exponent. Question for that one? Are we clear on how we identify the same terms?
Yes.
Okay, cool. So let's move on to the next one. So here, I would like you to do on your own. Rewrite each of the following by combining like terms. So it looks like this is the same term, the same term, the same term. The only difference is it has a subtraction here and it has a negative sign before or subtraction before addition. Even though we are combining like terms, we are still using the rule of integers. So if you could do number 5 and number 6, Go ahead, guys. I'll give you 2 minutes. I know right away you're going to say that. So let's look at example number 6. This is the last one we have. So, as we said, we could only combine like terms. Let's look at question letter A. So, what are the terms that are the same? What do you think are the terms that are the same? So, if
Like the 5x and the 9x.
the 5x and the 9x are the same. The 2 and the 4 is also the same. So it means we could end up, instead of 4 terms, we could simplify it using only 2 terms. So 5x plus 9x gives you how much? How much? Gives you
14.
14 what? It has to be specific all the time.
14x.
Correct. So don't forget that. Plus 2 and 4 is 2 and 4 is
6.
all right. So you're gonna tell me that at the end, wait a minute, can that be combined? Can I put this as 20x?
No,
Why not?
because it's not the same.
All right, good that you know that. So 14x is your final answer, and this is not possible. So you cannot make it 20x because they are not the same. Okay? Let's look at letter, which one I could make with you. So you do letter B. So I don't have space. I'll do letter C with you. Again, we have negative 2y and negative 6y as the same term, plus 7 minus 4 as the same term. Okay? How many y's do we have in this problem? How many y?
2.
So this is negative, wait, let me have pencil. So this is negative 2y, and that's negative 6y. How many y do you have?
2.
No, it's not 2. Think about this.
A 3.
Wait, before you keep on guessing, let me let you think about this. Malia, you're almost there. You're almost correct. So let's say, for example, you owe me two um you owe me 2 bananas. Let's say about that. And then you owe me again 6 bananas. So MD, how many bananas does someone owe me now? No, it's not. MD, you have the answer? So let's say MD owe his brother $2, and then the next day he owe him again another $6. How much do you owe now?
4.
Not really.
Wait, no, it's 8. 8.
It's not 8. It's not actually 8. What will it be? Oh,
Negative 8.
negative 8. You guys forget. So if you go for a number line, I don't want to go number line because that's 6th grade thing. So that's negative 2, right? So that's negative 2. You start negative 2. And then you go again for negative 6. So you're going to do 1, 2, 3, 4, 5, 6. So you jump negative 6 again. It goes this way because it's a negative. So where will it be? So 2, 3, 4, 5, 6, 7, 8. That ends at negative 8. So therefore, that's negative 8y. You could always go back to the number line if that will help you. If you forgot the rule of integers, that's fine. And then here we go. 7 plus 7 minus 3. So it looks like that 7 minus 3, what will it be? 7 minus 3, what will it be?
4.
Yes, of course. 7 minus 3 is 4. So, and 7 has a bigger absolute value than 3, the negative 3. So we take the sign of positive 7 for the final answer. So this is our answer for this problem. Question. I would like to see your work, and let's see how you're gonna answer them, and then tomorrow we're gonna have another set of this kind of work. So with that said, in your Google Classroom, that's a different one. In Google Classroom, work on that. It is in there. I put it here in Google Classroom. So complete this worksheet. I'll look at it today and we'll discuss some misunderstandings if there is tomorrow before I start the page 3 and 4 of this worksheet. Question, everyone? No, you could start working then, and I'll check with you in like 2 minutes.